Let's update this Jupyter notebook to train LeNet to classify traffic signs. LeNet turns out to be a pretty good network for traffic sign classification, so I encourage you to try this out on your own first. If you have trouble, you can come back and use this video as a guide. The traffic sign dataset is in color, so it is a more complex dataset than MNIST, and you might want to use a GPU to train it. You can use Amazon Web Services, which has a service called Elastic Compute Cloud, often referred to as EC2, which allows you to launch a virtual server, also known as an instance, with a GPU attached. When you launch an EC2 instance, you have to choose an Amazon Machine Image, or AMI. This AMI determines the operating system and pre-installed software for your instance. Udacity has already created a Udacity CarND AMI that comes with all the software you need pre-installed, so you can select that. Next, you have to choose an instance type, which defines the hardware on which the AMI will run. There are a lot of instance types, so filter them by type and focus on GPU instances. You can select the G2.2x large instance because it's big enough for this project but not too expensive. Before you actually launch your instance, edit the security group so that you can connect to port 8888. That's the default port for Jupyter notebooks. Add a rule to allow you to connect to port 8888 from anywhere. Be aware that this means anybody anywhere can connect to port 8888 on your instance. And if you have a Jupyter notebook running, they can use that notebook to run any code they want on your instance. So be careful with this and make sure to turn off your instance when you're done. When you launch your instance, AWS asks you how you're going to log in. In this case, the Udacity CarND AMI comes with a user already set up, so you can proceed without a key pair. Wait for the instance to pass its initialization checks, then note the IP address and log in. Connect to the instance via SSH with the username CarND. The password is also CarND. Once you've logged in, activate the CarND Term 1 Anaconda environment, which comes pre-installed on the AMI and contains all the software you need for this project. Clone the LeNet lab, download and unzip the traffic sign dataset as well. Now launch the LeNet Lab Solution Jupyter Notebook. Connect to the notebook using the IP address of the EC2 instance along with the port number 8888. Now run the entire notebook to verify that everything works. Congratulations! You are now able to edit the LeNet notebook using the power of a GPU on AWS.